Hello everyone, it's Benny, and today I'm going to be showing you how to make Pong, using the framework that we set up in the last video. So in the last video we sort of set up the framework, the game engine, the physics engine, all that stuff. And in this video we're actually going to be using all those things to make Pong. So, let's go ahead and get started. But actually before we do that, I would like to bring up that there's something I forgot to do and the whole setting up the game engine thing. So if I go over to my main class, there's something I forgot to do. And it's in the sort of initial initialization, I guess I could say. Sounds a little bit weird, but you know, the one we're creating the display. We're setting up everything to have a window, or a game in our window. So, the thing I forgot to do here is, when we get input, Lightweight Java Game Library does input using a class called keyboard, and it works a lot like the display class in the sense that it's static and you don't need to create and destroy it. And basically I need to do that here if we ever want to get any user input at all. So in my initialization of display, I'll just do keyboard.create, and this will create in the, well, not create, that's a bad word, but it will set up this static keyboard class so that we can get any user input. And in my cleanup method, I'm going to destroy it, and I'll do whatever it takes to set it back or clean up. Again, Lightweight Java Game Library handles it for us, so we don't have to. And now with that all out of the way, we can go ahead and start making Pong. So let's go ahead and get started. The very first thing I want to do in creating Pong is just get a ball. Because the ball's sort of the center of Pong, it's how the whole thing works. You just keep your eye on the ball and you try to keep the ball from going off the screen. Very simple. So I think the ball is a nice place to start. And I don't want to make it do anything fancy just yet. I just want to make it show up. So how do I do that? Well, first off, you have to remember that in the last video, we decided that everything in our game would be a game object. We simplified it. So the very first thing we're going to have to keep in mind is that our Pong ball will, in some form or another, need to be a game object. And the other thing we have to keep in mind is that when we made the game object simplification, all of our updating and rendering, you know, the game logic and actually making it be displayed, yeah, all that is being done based on this objects list. So if we actually want the ball to show up, we will need to add it to this list of objects. So, with that all out of the way, let's start talking about how to make a ball. Well, we clarified that it had to be a game object, or it can't show up based on this framework. Or at least not very easily. I shouldn't say it can't show up. Just with the system we have, it would be very difficult to make it show up otherwise. So it's going to be a game object. So, our game object already provides for us an x position, a y position, a size in x, and a size in y. It provides us methods for getting all those, and a method for getting the center and y. And also provides an update and a render method. So, you might be tempted to say, okay, I'm just going to create a game object, ball. It'll be in there. But this isn't really going to work. And the reason that won't work is because game object is an abstract class. I mean, it's a concept. You can't have anything that's just a game object. It's going to be, it can be classified as a game object, but it can't just be a game object. And I went into a fairly in-depth, I think, speech on why that is in the last video, so I'm not going to go any further into it. So we're going to sort of break down the classification. We're going to create our own class for the ball. So I'm going to create a new class. I'm going to just put geo in front of it to dictate that it's a game object. I'm going to call it ball. So geo ball, and this will extend the game object. Extends the game object. So it's inheriting from the game object class. And this way, we have something that it is its own unique thing. It's the Pong ball, but it can still be classified as a game object because of inheritance. And that's pretty much exactly what we want. So, first off, it's going to be a little bit mad at me because I have an abstract update method in game object that I'm not implementing here. So I'm just going to create public void update, and it also wants me to put @override, or it'll give me a warning. This doesn't actually do anything to your code, it's just NetBeans gets mad at you if you don't put it. So I'm just going to put it there. And now we can do mostly anything we want here, just to make, a game object, a ball to show up and make it work like the Pong ball. So, the first thing I want to do in creating the Pong ball, now that we have something that can be at least understood by our game engine very easily, is I want to set it up so that I can put it anywhere I want on the screen, and I want to have it some sort of size. So, to start off with, I'm just going to set it up so that I can put it anywhere on the screen. So I'm going to create a constructor for it, and that's where I'm going to put it wherever it is. So I create a public constructor for it. And now, you may be tempted to create variables for positioning, but GameObject already provides them for us. So the way I'm going to do the positioning is I'm going to take in a float for the X position and a float for the Y position. This way I can create it in any position I want. And I'm going to set this .x, which is the X inherited from GameObject, equal to whatever they pass in. And this .y, which again is the inherited Y value, to whatever is passed in Y. And that will put the that will put the ball at whatever location that we happen to pass in when we're creating it. And that's good. That's exactly what we want. Now the other thing that the game object needs, it needs a size in X and a size in Y. And that's going to, first off, those are going to be the same since it's going to be a square. It's not going to be an actual circle, it's just going to be a square. It's Pong. But the thing about that is we don't want to have to pass in the size, because the size is going to be the same across every ball we create. Even though there's only going to be one, the size is always going to be the same. So I'm going to make it a constant. I'm going to public static final. I'll make it an int. I'll call it size. And I'll just try 16. And these variables are sort of, I guess you could say artistic. You can put them to whatever you think makes it work. But I'm just going to put it to 16 for now, and put the size x equal to size, and size y equal to size. And you don't need this dot here, technically speaking, but I'm just putting it here for clarity's sake, to explicitly state, hey, this is coming from the GameObject, what's it called? The GameObject class. We're inheriting these values. And actually, really, since we've initialized all the variables that GameObject requires, this should be enough to get something to show up. So let's go ahead and create our first object that's actually in the game. So first off, we have our game. This is all the game engine creates. So anything we want in our game we'll need to create here. So I'm going to create a ball. And I'll initialize it and make it a new geo ball. And now I need to put the X position in the Y position. Well, I want the ball to be the center of the screen. So I'm going to do this by doing display.getWidth. And remember, I'm doing this X and Y basis, so to get the center in X, I'll get the width. I'll divide that by 2. Not F2, but divide by 2. I'll hit Control-Shift-I, so NetBeans will import it. And you have to remember that it's drawn like sort of a wall, and the ball is drawn like sort of outward from that line. So I actually want this point right here, if that makes any sense. So I'll need to subtract half the size of the ball in order to get it in the actual center. So I'll take geoball.size, and since it's a constant, I can do that. I'll divide it by 2. And for size and y, I need mostly the same thing, except this time it's height divided by 2. And other than that, it's exactly the same line of code. And that should put the ball at the exact center of the screen. But of course, if I run this, you should hopefully know that nothing's going to show up. And the reason is, everything in our game needs to be inside this objects list. So at the bottom, I'm going to do object.add. I'm going to add the ball. And that should add the ball to our game. So now if I run, look right there. We have our first game object in our game using our own game engine. Congratulations. So that's a start. But now that we have the ball there, it's not that interesting just having a static ball sitting there. So let's go ahead and make the ball move. So first off, I'm going to want some variables to keep track of the ball's speed, because I think the ball's speed's going to be able to change, maybe not so much in X, but definitely in Y. Our Y speed is going to be able to change. So I'm going to make... Well, actually, yeah, our X speed's going to have to change too, because it's going to have to reverse, it's going to have to bounce off. So our X and Y speeds are both going to have to change, so I'm going to make them as just regular variables. I'll call it velocity in X, and public float velocity in Y. And if you don't know, the only difference between velocity and speed is velocity takes direction into account. So speed can be in any direction, but velocity is speed in a specific direction. Now I'm going to need to initialize these to some values. And I'm going to create constants for this. So I'm going to create a public, final, we can make them floats. I'm going to make a max speed x, because it's going to be able to change. So max speed x, I'll initialize to 4. And for our max speed y, now I want to be able to move just a little bit faster in y than it does in x. So I'm going to make it double. I'm going to make it 8. I'm going to initialize... Well, I need to initialize these variables in the constructor to the velocity in x, velocity y. So my x, I'm going to initialize it to max, whatever my max speed is. But I'm going to make it negative, because that'll make it move towards where my player is going to be. Well, obviously it's not going to make it move towards the player, since the player is not there yet, but it's going to be where my player will be when I create it. So that's why I'm setting it to that. And velocity y, I'm just going to initialize to nothing. I don't want to move on the y-axis at first. And of course these variables mean absolutely nothing if I'm not using them to affect my position. So I need to determine what I want to do every frame of my ball. What I want to do every frame is I want my x position to increase by whatever my velocity in x is, and I want my y position to increase by whatever my velocity in y is. And hopefully this code makes sense to you without explaining it. It's not that complicated. But basically every single frame, I want my x position to, again, increase by whatever my speed in x is. So there. Now, if I close out of main, because I don't need that anymore, now if I hit run, I should have the ball moving across the screen towards the left-hand side. So if I hit run, hey look, the ball's moving. So there, we have created a ball that's moving across the screen. And for now, I think that's enough of the ball. We can go back and finish the ball later, but for now I just want to leave it alone and move on to some other parts of the Pong. So, let's move on. Next I want to create the player. Because, I think it makes sense just to have the next thing be the player. So I'm just going to create another thing, and it's going to be a game object, because everything in our game is a game object. And it's going to be called the player. You could say player paddle if you want, but I just want it to be the player. And it's going to extend game object, because everything extends game object. It's going to have a public constructor, and also public void update, since it inherits that from game object. And it needs @override above it, because otherwise NetBeans will hate you forever. Still don't understand that, but it's okay. And now, for position, I want the exact same setup I have for the ball, so float x and float y, it'll take those in as parameters. And whatever x that they give us, I want that to be my x location. Whatever y value they give us, I want that to be my y position. Now size is going to be a little bit different for our player, because our player is going to be a little bit bigger in y than it is in x. I mean, it wouldn't make sense to have a giant square as a paddle. That would just be weird. I mean, you could have it like that if you want. I mean, no one's stopping you. It's just, I would rather have my paddles look like the traditional paddle look. So I'm going to create constants. So public static final int for size in x. And my x size, I want that to be just 16. And for my size in y, I actually want to do something a little bit interesting here, because I want my size in y to sort of be relative to my size in x. So let's do size x times 7. And we'll see how that works out. And if we don't like it, we can always go back and change it. So there. So this .sx is size x, and this .sy is size y. And that should be everything we need to get a player to show up. So I'm going to go back into my game, and now I'm going to create a Geo player, call player. It's a new Geo player, and now I need to decide where I want to put it. Well, in X, I want that to be all the way on the left of the screen, so that's just 0. And for Y, I want it to be right in the center of the screen. So I'll do the display.getHeight divided by 2 minus geoplayer.sizeY divided by 2. Same formula we used for the ball. And now if I run, I should have a player in the center, but I don't. So that leaves the question of why do I not have that in? And the reason is because I forgot to add it to the game. So just do objects.addPlayer at the very bottom and hit run. And now we have a player paddle. And again, if you don't like the way it looks, you can change it, but personally I think it should be fine for our purposes. So I'll just leave it as it is. So we have a player, but of course there's a couple of immediate problems with this. Obviously the ball goes straight through it, that's not supposed to happen. And if I hit any movement keys, nothing happens. So that's going to be our next order of business. And we can tackle those in really even order, but I'm going to do input first, just because why not? So, input. Well, first off, our input is going to be in the getInput method. So that's where we're going to put that. And if we wanted to, we could separate this out to have all the input specific for the player in the player. But since that's going to be our only input, I'm just going to put it in the main game. So here's how we use input. As we saw in the beginning of the video, Lightweight Java Game Library has a class for input called keyboard. Well, that's for the keyword input, that is. We don't need any mouse input, so we're not going to worry about that. So the way we do this is we do if statements. So if the keyboard class has a method called isKeyDown, and the way we pass in a key is we just do keyboard.key underscore whatever key we want. So I want this to be, well, how should I say this? Okay, I want the player to be able to be controlled by either W and S of the W and ASD controls, so just W and S, so we can move up and down, or the up and down arrow keys. So I'm going to do if key W, so this is going to be what we do for pushing the up button, or we're doing keyboard.isKeyDown, keyboard.key up. So this is all the movement of up. Then we're going to need to import keyboard class. Now we're going to do something. And what I want to do is well, first off, this leaves us with a couple of problems. First off, we can't really access the player here because the player's in the game constructor. So I'm going to fix that immediately by just going and creating the player as a field. So I'm going to create a public, actually I'm going to make it private. Private geo player, not plate. How do I get plate out of plate? No, never mind. Just never mind. I must be hungry or something. So geo player, call player. I'm just going to initialize it here. This way we can access player from the getInput method. So now we can do player, and we can do a couple of things here. Now first off, we shouldn't be able to access this. This should. That's really interesting. I don't think we should be able to access this, but apparently NetBeans is letting us. But oh well, I'll figure out what I did wrong, if I did anything wrong there, some other time. Right now I'm focused on getting the player to move. The way I'm going to do this is, since we only need to move in one axis, I'm just going to have a single move function in the player class, and I'm just going to make it take some magnitude. So if we're pushing the up key, I want to move with a magnitude of 1. I'm going to do the same test except for the down key. So I'm going to just copy the if statement. Except this time I'm going to do keyboard.key underscore down and keyboard.key underscore s. I'll do player.move with a magnitude of -1. And the way I'm going to do this is first I need a method called move. So that's going to take in some parameters. And it's going to be some magnitude. It's going to be a float. And this is how we're going to do player movement. First off, if we're going to have some magnitude, we're going to need some speed to move at. So I'm going to create a constant speed. This will be sort of like the normal speed that we have. And we use magnitude to control how much of this we're moving. So our sort of standard speed I'm going to initialize to I'm going to make it a float, going to make it called speed, and initialize it to 4f. So the same speed as the ball, in x that is. And the way I'm going to move is actually the same way I moved the ball. I'm going to have to take my y position, I'm going to add my speed multiplied by my magnitude. And that should at least be able to move me in y. So if I hit run, you'll notice my player is moving. Still not bouncing. Actually 4 might be a little fast, but I'll adjust it later if I need to. But yeah, we have movement. And hopefully this makes sense to you as to why it is. We're moving our position by whatever our speed times our magnitude is. And the way we're determining input is just with the keyboard class's methods that checks if some key is being pressed at the moment. And there. So, now we have the player moving. All we have left to do is determine if the ball has hit the player and make it bounce if it has. So, doing this is actually a little trickier than it seems at first. So I'm going to do it sort of the way you'd think of first, and then I'll sort of go back and explain why there's a bit of an issue with that. So, first off, if we're going to check for collisions between the player and the ball, and, well, actually let me start that again, because that's not what I wanted to say. If we're going to have the player check for collisions between itself and the ball, then first off the player's going to need to know about the ball. So I'm going to pass in the ball as a parameter, so this way the player knows about the ball. And in here I'm going to make it take in a geo ball called ball. And the way I'm going to have this work is I'm just going to have some field in the player class. I'll just make it a private geo ball called ball. And I'll just do here this dot ball is equal to whatever they pass in as the ball. So now the player knows about the ball. And collisions are easy enough with our physics engine. We just do if physics dot check collisions between the player and the ball. So if the ball has hit the player, then we want the ball to reverse its direction in x, because that'll be the same as bouncing. You know, if the ball hits a player, we want to just reverse. So reverse x. And now I just need to create a method for reverse x. So I'll create a method in the ball class called public, it'll be a public void called reverse x, because that's what I called it. And this will just take my velocity in x and multiply it by -1. And that should reverse it in x. So let's just hit run and see what happens. Hey, look, the ball bounced off our player paddle. So now we have collisions. Congratulations. But of course, it's not quite that simple. And here's why. The reason why it's not quite that simple to do collisions is because in Pong, if the ball hits a little bit higher on the paddle, it sort of gets an angle. It sort of starts moving up in Y a bit. So we need to sort of emulate that effect. And here's how I want to do it. So here's my thinking. Let's say this sort of line right here is my player. And this sort of square right here is my ball. So if the ball just hit straight on right here, then I would want it to move a fair distance. You know, I'd want to move sort of angle this way. But if the ball, for some reason, hit right here instead, I want to have a little bit of a sharper angle. And the angle sort of decreases the closer it gets to the center, and then reverses, so it ends up being sort of like a ray like this. Sort of. So the way I'm going to emulate that effect is I'm just going to take the ball and the player, I'm going to find their center point. And I'm going to take the difference of it. And this will let me know how close to the edge of the paddle the player hit the ball, or the ball hit the player, depending on how you want to look at it. And this will allow me to determine how steep of an angle the ball should start moving at. So that's what I'm going to do. So first off, in reverse x, I'm going to take the player's center, or the center of whatever we happen to hit, as a parameter. So take float center. And this is where our getCenter method comes from. So I'm going to take getCenter y as the parameter to reverse x. And now, to sort of make it move in y depending on what the distance between the center is, I'm going to take my velocity y and add whatever the difference between the center of the ball is and the center of whatever we hit is. And if we wanted to run this right now, that would be fine, but you notice it's a bit too sensitive, because this calculation right here is giving us the literal number of pixels between the center of the ball and the center of the player. So if it's only 2 or 4 pixels off, that's not that much, but it's already pretty much halfway to its maximum speed in y. So it's, yeah, we're going to want to sort of tone this down a bit. So I'm going to do that is with a damping constant. Create a float called damping. I'm going to set it equal to, I'll set to 0.05. And we'll just see how that works out. So the way I add in the damping constant is just multiply this calculation times damping. And now this should cause the ball to reverse in x and also gain some velocity in y depending on how close it is to the center. But there's still a problem with this, and that is, since this is just constantly being added, this can be greater than our maximum speed in y. So we'll just need to make sure this never goes over that. So after this calculation, if my velocity in y is above the maximum speed I'm allowing in y, then I'll just cap it by saying, okay, I'm going to decrease it to my maximum speed in y. And if my velocity in y is less than the negative maximum speed in y, because, you know, it can go both directions, I'll just set it equal to the negative max speed in y. And there. So now this should finally be a completely bug-free version of this reversal method. And it should take into account that. So if I move up like this, you notice it's moving slightly up based on that. If I put it down, it's moving down. And if I'm only slightly off, it has a very slight angle. So, all that has finally produced the effect that we want. So now we've gotten pretty much as interesting as we're going to get with just the Pong ball and the player. So I'm going to go ahead and create an enemy paddle for us. So I'm going to create a new Java class called GeoEnemy, spelled correctly. And it will, again, extend GameObject. It'll have public void update, because it inherits that from GameObject. It needs @override, or NetBeans will be mad at you. It also needs a constructor. It'll take in the x and y positions just like our player and our ball. So float x, float y, and the x in our game object. So this dot x is equal to x. This dot y, not file for some odd reason. This dot y is equal to y. And now we'll need size. I want enemy to be the same size as this, so I'll just copy these size x and size y constants from the player. And this dot size x is equal to size x, and this dot size y is equal to size y. So there, we've created the sort of initialization of an enemy object. Now, in our update function, it's also going to need to check for collisions against the ball. So first we need to know about that. So in my constructor, I'm going to take in the ball as a parameter. So GeoBall ball. This dot ball is equal to ball. And I'll create a private GeoBall called ball. Actually, did I remember to make that private in the player? Yeah, okay. Just check. Oh, sorry. So there. Now, we have a GeoBall called ball. It's all set up right here. And now we need to check for collisions in the exact same way that we checked it for player. So if physics.checkCollisions between this and the ball, so if we've collided, then we want the ball to reverse x. With and the center of us is our get center in Y. So there. We now have an enemy paddle sort of set up. Not quite finished yet. But if I go ahead and add this, go here, just do geo enemy. Enemy is a new geo enemy. And for my initial position in Y, I want that to be display.getWidth, because I want it to be all the way on the right. And I'll have to subtract my size in X, because it's drawn from left to right. So if I take that, and for my Y position, I want that to be the center. So I'm just going to copy the rest of the parameters from the player, and there. And lastly, I just need to add it to our list of all objects in the game. So add enemy. And now if I hit run, I have an enemy paddle. And if I just leave it like perfectly still, it shouldn't set off the calculation for movement in Y, so it should just bounce back and forth. But if I move slightly, then it'll move up, and the enemy just sort of sits there and lets it pass. That's not very exciting. We want some AI for our enemy. So let's go ahead and create the enemy AI. So, in order to create enemy AI, let's think about what we want the enemy to do. We just want the enemy to chase after the ball and hit it, right? So, in order to do that, we'll need to know the distance between the enemy ball and the paddle, and if it's greater than a certain amount, then the enemy will start moving towards the ball, if the ball is above it in Y. And if the ball is below it in Y, then the enemy paddle will start moving down to a sort of chase after it. So the way I'm actually going to do this is the exact same way I used to calculate the Y speed for the ball. And I know that might seem weird, like how could that possibly also work as AI, but I'll sort of explain as I go along. So first off, what I'm going to do is I'm going to create a float for speed. This will be however fast we're moving in Y. At the end of this, I'm just going to want to add my speed to my Y value. And just like in the ball, I'm going to have some maximum speed. So final float max speed Y, set it equal to 4, because that's the same max speed as the player. And I'm also going to create a damping variable, because we had that in the ball. I'm going to set it to the exact same value. So, let's figure out how we're going to calculate the speed. Well, first off, we need to move towards the ball if the ball is above us or if it's below us. So the way we're going to find that out is we're going to take our center in Y, so get center Y, and subtract the ball dot get center Y. And this actually may be backwards if I am remembering incorrectly. So we may end up just needing to reverse this. So if there's a problem, we'll just end up reversing this, and that should fix everything. But I think this is correct. So now that we're going to set it to this, and we're going to, and since that's the absolute number of pixels, we just want to multiply that by our damping variable. And this will give us the distance between the enemy and the ball, or rather it will give us 1/20th of the distance between the enemy and the ball. So every frame the enemy paddle should move 1/20th of the distance between itself and the ball. And unless that speed or that distance happens to be greater than our maximum speed that we can move, in which case we'll just move the maximum speed we can move. And in order to make sure of that, we'll use the exact same thing we did for the ball. So if our speed is greater than our max speed Y, then our speed will be equal to our max speed Y. Otherwise, if our speed is less than our negative max speed Y, our speed will be equal to negative max speed Y. And I remember that in the ball. Yes, I did. Okay. I'm just being paranoid. Sorry. So this should give us a very simple AI algorithm. It should just cause the enemy to chase after the ball. So, if I hit run, now, we should have the enemy Paddle chasing after the ball, but it's going in the wrong direction because I did the calculation backwards. So I'll just do ball.getCenterY minus whatever our center in Y is. And now I'll hit run, and now this should cause it to chase the ball. And it is. The only issue of this is the ball can go straight off the screen. Which will lead us to the next thing we're going to do, which are the walls. So to create the walls, I'm going to right-click on my package, create new Java class. I'm just going to call it GeoWall. And this will actually be probably the simplest of everything we've created so far. It's going to extend GameObject like everything else. We're going to have a public GeoWall. Take float X, float Y, and the ball can collide with it, so we'll take a GeoBall ball. We'll keep track of a ball, or a private GeoBall, called ball. And this ball will equal, and this dot ball equals ball, and this dot x equals x, and this dot y equals y. And now we have size x and size y. I've sort of debated on whether I want to do this individually or not, and I think I'm actually going to make these sort of independent. I'm going to take these parameters. And the reason I'm going to take these as parameters rather than taking them in as sort of hard-coding them is because, in theory, I could have a wall that would be perfectly in the center, and it would be the same object, it would just be a different shape. So not all walls are technically the same shape. And in our case, they will be, but this just makes it a little bit more flexible and expandable if we want to change it later on. So I'll say this dot size x is equal to size y, x and this dot size y is equal to size y. Although despite this, I'm still going to have constants for the size x and size y, just because in our case they will be the same, but I want to leave it as an option in case you want to have some wall right in the middle of it for some odd reason. And size in x I'm going to set to... Actually, I won't be able to make constants for this, since this will depend on screen resolution. So I actually cannot make... I cannot make the... What am I trying to say here? I'm sorry, I just had a complete brain freeze right there, but... I can't make them constant because they rely on some variable data. In this case, this is width of the display. So I'll just create some constant called std size for standard size. I'll set it equal to 16. And this will sort of give us a basis for the size of the wall. So, now that I've done all that, let's create a wall. So I'm just going to create a GeoWall in our game called wall1. Set it equal to a new GeoWall. And for our location in X, this one I want to actually just be 0. And for our location Y, I actually just make this one the lower corner. So it'll be 0, 0 for this one. And for size in X, I want that to be the width of the screen. And for size in Y, that'll be GeoWall.standard size. And we'll also need to pass in the ball. And we also need upper wall, so I'm going to create another wall. It'll be a new GeoWall at 0, 0. Actually, no, not 0, 0 this time. 0 and display.getHeight minus the GeoWall.standard size, because that'll put it right at the top of the screen. But again, same size, display.getWidth, and the standard size for the size in Y. Dot standard size. And lastly, I need to pass in the ball. I'm just going to, at the end, add these to the game. So add wall 1, and add wall 2. And there. So now I should have walls, but they aren't really doing that much yet. So I'm just going to create an update method, or override the update method, just because everything overrides the update method. And add the @override, because NetBeans will hate me otherwise. And do the exact same physics check we've done all along. So if physics.check collisions between this and the ball, then I want the ball to reverse in y this time, because it would make sense if we hit something above us and we bounce in x. We want to reverse in y, which actually means we need to go in the ball and create a public void reverse y. And this one actually is really simple. It just takes velocity y and multiply it by -1. I'll just call this a straight bounce, because we don't want any weird changes in x velocity if it bounces strange or anything. So I'm just going to leave it just like that. So now if I hit run, we have walls. And if I bounce it, it should bounce off the wall, and the enemy paddle is chasing after it. So, depending on how you look at it, we've just successfully created Pong. The only issue is we don't have any way to detect score, and if the ball goes off screen, we're screwed. So that's what we're going to do now. So if we're going to check for score, we first have to think of where it would make sense to put that. Because we could, in theory, put it in the ball class, but I think scoring's more of a game level thing. It's something that involves the whole game and not specifically the ball. So I'm going to actually put scoring inside the game class. So I'm going to just have a private int for player score and a private int for enemy score. And I'm going to initialize my player score to 0 in my constructor, and my enemy score I'm also going to initialize to 0. And the way I'm going to do this is, in the update function, I'm going to check if the ball has gotten past either of the paddles. So, the way I'm going to do this is actually really easy. I'm going to do if ball, which right now is a local variable in the constructor, so I'm going to move the ball to a field. So now I can access it from the update method. So if ball.getX, so our ball's location in X, if our ball's location in X is above the width of the display, that means that it's gone past the enemy paddle, which means our player has scored. So if that happens, then I need my player score to increase, because our player has scored, and I'll want my ball to reset its position. So we're just going to leave that like that for now. And if my ball.getY, get X, is less than 0, that means our enemy score has scored, so our enemy score ++, and we're also going to reset the position. So, whoops, got parentheses, and there. So now we just need to implement this reset position method. So here's how I'm going to do the reset position method. I'm just going to put it right under the update, public void reset position. Now, first off, if we want to reset our position, we'll need to know what position we want to reset to. So I'm going to have to store my starting position. So public float start x and public float start y. And in my constructor, I'll need to set my starting x to whatever they pass in, and my starting y to whatever they pass in. Now, when I reset my position, I just need to set whatever my current x is to my starting x, and whatever my y is to my starting y. And that should reset my position in terms of just resetting that. But I want to go a little bit further than this. I don't want it to retain any of its vertical velocity once it's reset, so I'm just going to set my velocity y back to 0. And I'm also going to reverse my direction in x. And the reason I'm going to reverse my direction in x is because I don't want the ball to immediately come back to whichever player just lost. I want it to go to the player that just scored. So this way, hey, it's going to reverse and go back to whichever player scored. And that should be almost everything. The only sort of final thing I want to do is under the render method, I want to set the title of my display, so I'm going to use display.setTitle to a new string, which has score, and then else my p plus player score, and e enemy score. And this way I just have a visual indicator of what scores people have. And now if I run this should be the final version of Pong. You notice I have my score panel right there. And now if I start trying to score, we will see if this actually works. So, whoops, I lost, and you notice it goes back to my enemy once he scores. So now if I try to score, because I want to get at least one score off on this guy. And yeah, it actually is, oh dang, I lost. It actually is not that hard, I'm just sort of failing right now. And if you wanted this to be a little bit more challenging, you could just decrease the damping for the enemy when in his AI calculation, and that will make him move just a little bit slower. Oh, I almost got him, oh well. Oh, scoring is working anyways. And yeah, so hope you enjoyed, and yeah. So if you managed to make it through this far, then congratulations, because seriously, you earned it. This was definitely not easy, especially if this is the first bit of game development you've ever done. I hope you've learned something. I hope you understand Pong better now. And if you have any suggestions for what you think the next game should be, then I'd love to hear it. I don't want to do 3D just yet. I want 3D to sort of be the third thing, because it's too big of a leap to go straight from Pong into 3D gaming. So I'm going to leave off on 3D until the game after this one. I want to have just one more game to sort of be an example, and sort of just getting used to how game development works. And after that I want to get into 3D. So, third project, definitely getting to 3D. You can have suggestions about that, or if you have any suggestion about what the next thing you want to be, then please post that too, because I honestly, at this point, am not quite sure what I want to do as the next game, or as the first 3D game. So if you have any suggestions on that, please post them in the comments, because I would love to hear it. So thank you, and I'll see you next time.